Good evening, everyone, and welcome to Strait Science. Strait Science is an evening science seminar series put on by University of Alaska Fairbanks Northwest Campus in Nome, Alaska, as well as University of Alaska Fairbanks Alaska Sea Grant, and you're in the home office tonight. So the Northwest Campus and Alaska Sea Grant, we are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. Now tonight, this is really going to be an interesting Strait Science. Personally, for me, we're back on the waterfront, and we have Jim Murphy talking to us tonight from Juneau. Jim Murphy is the research biologist with NOAA Alaska Fisheries Science Center down there in headquarters. And he is the lead biologist for the Northern Bering Sea Ecosystem and Surface Trawl Survey. So we're really glad you're here tonight, Jim, to tell us, especially since we weren't able to have the Northern Bering Sea Bottom Trawl Survey do their survey of the Northern Bering Sea. We're so grateful to hear what you found on the surface trawl surveys. And with that, we're so glad you're here. Take it away, Jim. Thank you so much.
Well, thank you, Gay. Yeah, it's great to be invited back to talk a little bit about this survey that's been going on for quite a few years now. I think maybe though, just before I begin, I just want to emphasize that we're all concerned for the communities in this region, not just because of the recent plane crash and the impact that's had on the community, but just also because of the uncertain future that the region is facing with warming Arctic. So I also want to point out before I get started that this survey requires a whole team of scientists to make it happen every year. And I want to thank all of the investigators and all of our collaborators who have contributed to the survey. And I do want to thank Alaska Sustainable Salmon Fund and Fish and Game for their continued funding support for the surveys, as these surveys would not be possible without their support. Let me see, hopefully I can get this to, yep, there it is, we're moving. So this figure here shows our survey grid in 2024. It was conducted off the chartered research fishing vessel, the Northwest Explorer. We started and ended in Nome on August 30th and September 20th, 23rd. And we had a port call in Nome on September 12th. And Jen Bell and Luke Hensley have been a huge help during our port calls in Nome, and they've been a big asset with shipping samples out of Nome since I've stopped trying to ship samples out of Dutch Harbor the last couple of years. So the figure here shows the stations, and I've also added the spatial strata that we use to define the different regions of the survey. We're planning a very similar survey design for 2025, but if everything goes as planned, which we'll also have to find that we will probably be adding about 6 days to the survey starting in 2026, and this will allow us to sample more of the Bering Strait region and some of the offshore regions of the Northern Bering Sea south of the St. Lawrence Island. We conduct multiple operations at each station, and we start with a CTD, which stands for conductivity, which is a measure of salinity, so conductivity, temperature, and depth. And we also have sensors on the CTD to measure dissolved oxygen, chlorophyll fluorescence, and a beam transmissometer, which gives a measure of the turbidity. The CTD is attached to a rosette water sampler, and we collect water at multiple depths to measure size fractionated chlorophyll A. We collect samples for E, D, and A. We collect samples for nutrients, phytoplankton species ID, stable isotopes, and other samples that are requested, and those samples will vary from year to year. Well, we collect data on the benthos with a benthic grab at each station, and so we use that to measure sediment grain size, the harmful algal bloom cyst density in the benthos, but we also measure fatty acids in the sediment as well. Benthic organisms like worms and clams are also collected for research on harmful algal blooms and also used for work on stable isotopes and fatty acid profiles. We collect zooplankton and ichthyoplankton at each station. And we preserve the zooplankton for detailed laboratory-based counts. And we also freeze samples of zooplankton for a variety of different research projects that are requested from each year. And we complete rough counts of zooplankton on board the vessel. And this is Jenna Barrett, who came out in 2022. So this allows us to provide a rapid assessment of their abundance, and that's used in ecosystem status reports for the North Pacific Fisheries Management Council. We collect information on the benthic community with a small mesh 3-meter beam trawl at each station, and the small mesh of this trawl is very effective at capturing the smallest ages, the smallest life history stages of crab, the age 0 or juvenile life stages of shrimp, and other small invertebrate species like shrimp. And so the last survey operation is a surface trawl. This is a rather large pelagic trawl that's been modified to fish at the surface, and this trawl is particularly effective at sampling pelagic species like salmon, capelin, herring, pollock, and saffron cod. So this figure shows how the average surface temperature has varied over time in our survey. And we've seen a fairly steady decline in temperature since their peak in 2019. And actually the temperatures in 2024 were the closest we've seen it over the last 10 years. And this, I believe, has been important to some of the improved foraging conditions that we saw in 2024. These two figures kind of highlight some of the zooplankton results that we have. The abundance of large copepods was above average in 2024, very similar to the numbers we saw in 2023. That's the figure on the left. And the figure on the right shows the lipid content of large copepods, and kind of unlike 2024, both the abundance and the lipid content of large copepods were well above average, and so that would mean that both their abundance and the quality of that forage was higher in 2024 than we've
Jim,
seen in. Yes.
Jim, this is Gay. There are some people that are not able to, and I see their point. If you could either move closer to your mic or feel free to speak louder.
Oh,
People
yes,
are,
I will. Hold on a second
yeah.
here.
Thank you so much.
I'm probably not speaking loud enough because my mic is over here. Let me do this.
We don't want to miss any of it. All your info.
Yeah, is that better?
Yes, it is. Thank you.
Okay, sorry. Yeah, it's hard to know exactly the volume, so thank you for pointing that out. I can go over this slide again, should I, or do you think?
Sure, it looks important. Zooplankton.
Okay, so
thank you.
So what we saw was the abundance of large copepods were similar to 2023. They were above average this year, and their lipid content, or the quality of copepods as a prey species, was above average. So that is in general, I think the foraging conditions in 2024 were were good, and it ties back to the cooler temperatures that we saw this year. So this is some results from the beam trawl. We only caught a few of the smallest snow crab, so that age 0, that first year, which is typically below 15 millimeters, is about the size of their first year. So these are really small crab. And there were really only present at a few stations. Overall, we didn't catch many snow crab. But what's interesting is the figure here on the left shows the progression of size over time. We started the beam trawl work in 2021, so this is I think provides very unique information on the age structure of the smallest ages of snow crab, and this is fairly unique to the survey because typically, like the standard bottom trawl survey, doesn't really isn't able to really catch snow crab less than about 30 millimeters. At least they're not very effective. So this has really helped provide this information gap on the early life history stages of snow crab. We also, it's the same thing too, the unique information we collect on shrimp is unique to the survey, and that's because of they're typically the very small size. We catch a wide variety of different species. The figures here show 3 of the most abundant species that we catch. The species called ridge crangon, which is crangon dolly, the figure on the right, is typically the most abundant species of shrimp, and they typically are found in the very near shore habitats of the Northern Bering Sea. The Kuro shrimp, which it's the Argus genus, and as well as the humpy shrimp, which is the Pandalis genus, tend to be more abundant in the northern region of the survey. And so we collect shrimp species also to provide insight into the benthic fluid web with stable isotopes and fatty acid profiles of the shrimp. We've monitored energy density of juvenile salmon for several years, and we use it to provide insight into their condition. Energy density varies primarily with the lipid content of juvenile salmon. And although we did see the condition of juvenile salmon energy density decline from 2023, they still had average or slightly above average condition in 2024, which is I think still a good positive indicator of their survival. So one of the key things that we've observed is that temperature plays a key role in the condition of salmon. So typically their condition is highest in these average or intermediate temperatures, meaning that their condition is lower in cold years and is particularly low in warm years. Interesting here, we see that temperature doesn't really play as big of a role in Chinook salmon compared to the other species of salmon, and this we think reflects the difference in their diet. So this figure here shows on the x-axis is the amount of lipid in copepods, and then on the y-axis is the energy density of salmon. And so in warm years, both the lipid content in copepods and the energy density in salmon is quite reduced. But this is particularly true in species of salmon that are planktivores. These are species like pink and chum. They feed on zooplankton. So you see a much stronger decline in the condition of those species in warm years and when copepod lipids are low. But then you see almost no variation in Chinook, and they're largely piscivorous, which means they feed on other fish. And so I think that buffers them from this sort of variation in zooplankton lipid. And coho are also piscivorous, but they are less piscivorous than Chinook, and that's why you see this more intermediate response in coho. So we started monitoring ichthyophilus infections in Chinook salmon in the Northern Bering Sea in 2021. This of course is a major problem in the Yukon River for Yukon River Chinook salmon. So the prevalence, which is the proportion of Chinook salmon infected in the Northern Bering Sea, has been relatively high. It's varied from about 33 to 67% of the Chinook salmon are infected. These are the immature Chinook that are infected with ichthyophilus. And those are the blue bars. And the red line is the intensity of the infection, which is really the density of the parasite in the infected fish. And we've seen that increase fairly steadily since 2021. And by combining both prevalence and intensity, you just multiply them together, you can get an idea of what the abundance of ichthyophilus is in the host population. And that has increased steadily since 2021. And I didn't include the estimates for 2024 because we only caught 3 immature Chinook, and so that's really not a sample size that is reasonable for evaluating the status of ichthyophilus in Chinook. So we've also been testing a variety of different prey species to get a better handle on the transmission pathways of ichthyophilus. We know they pick it up in the marine environment, so we're trying to identify that. And we also, this last year, we identified the presence of ichthyophilus in chum salmon. So that was a little bit surprising. All this research on ichthyophilus is ongoing, but we're hoping that the data we collect in the Northern Bering Sea can really help us gain a better understanding of ichthyophilus and the impact that this disease is having on salmon. So the abundance of juvenile Chinook is one of the key time series that we collect on the survey, and that's mainly because their abundance is used to provide guidance on future run sizes to the Yukon River. And we've seen this fairly steady decline in their abundance since 2013. And in 2024, they reached the lowest abundance that we've seen in the last 20 years. And so this means that we expect run sizes to the Yukon River to continue to decline for the next 3-4 years. This run forecasts are based on the relationship between juvenile abundance, shown in the figure here on the left, which is on the x-axis, and then the adult returns from those juveniles is shown on the y-axis. So their survival has been relatively stable over time, up until the most recent years when ichthyophilus started to become a major issue in the Yukon River. And so these figure on the right shows our run forecast. You can see the runs in 2022 and 2023 came just below our prediction range, and those are the years where ichthyophilus is known to be a problem in the river. So these forecast models don't account for ichthyophilus, so they provide an overly optimistic outlook if ichthyophilus continues to impact their survival into the future. And there is some indications in the Yukon River this year that infection levels are possibly beginning to drop, but a lot more work is needed to determine how well and if we can project future states of ichthyophilus in Chinook salmon. And we're kind of working on those, but until then, all these outlooks is just a cautionary tone. Is that if you think ichthyophilus is going to be a problem, then you need to kind of adjust the outlooks accordingly. On a brighter note, the abundance of chum salmon increased significantly in 2024, and they appear to have recovered up close to their peak levels. One caveat to this estimate, if you look on the figure on the right, is that chum salmon distribution is very patchy, and most of the chum salmon were captured only in a couple of stations. So this type of distribution can lead to inflated abundance estimates. However, I think it's reasonably safe to infer that their abundance was above average in 2024. And with the improved foraging conditions in 2024, the outlook is fairly positive for chum salmon. One thing that was really interesting in this year was the significant increase in Arctic lamprey, and it's much higher than anything we've ever seen over the last 20 years. And if we think about what could possibly have changed, like in the Yukon River, most of these lamprey are originating from the Yukon River. I think it's possible that the high mortality that we're seeing in salmon during their spawning migration could be benefiting Arctic lamprey. The early life stages of lamprey are known as amicetes. They're detritophores, and so they may be benefiting from the increased mortality in the carcasses of salmon within Yukon River main stem. The abundance of capelin also really increased significantly in 2024, and I think this is really in response to the cooler temperatures we saw in the Northern Bering, because they're known to be very sensitive to temperature shifts in the Eastern Bering Sea. And they're really important forage for fish, for seals, and birds. So good to see their numbers return to near peak levels this last year. Herring are also an important forage species in the Northern Bering, but their abundance has been below average since 2021. There are multiple ages of herring, so I think their biomass is going to be much slower to respond to improved survival conditions. And so hopefully we'll see their abundance recover over the next few years. The abundance of 8-0 pollock has also remained below average since 2021. And 8-0 pollock are typically distributed throughout the entire Eastern Bering Sea, with most of them distributed in the southern portion of the Eastern Bering Sea. So we are only sampling the northern extent of their distribution. So these north-south shift in their distribution will play a key role in their abundance in the Northern Bering Sea survey. And it's quite possible that just the cooler temperatures that we observed in 2024 could be limiting the northern extent of their abundance and contributing to below average abundance in 2024. So the final data set I want to show is the biomass of jellyfish, which was above average in 2024, very similar to what we saw in 2023. And the biomass of jellyfish is primarily composed of a single species, the northern sea nettle, or Chrysora melanaster. The role of jellyfish in the pelagic food web is not really understood that well, but high biomass of jellyfish is generally thought to reflect improved productivity of the pelagic ecosystem. And this last year, the high biomass of jellyfish was used as a positive indicator for the Bering Sea ecosystem status report. So maybe a lot of jellyfish is a good sign. So and that's all I have for you today. I wanted to leave you with a few photos of the people who helped with the survey and have contributed data on the presentation, and just part of the team that makes the survey happen every year. And I'll take any questions.
All right. Well, thank you, Jim. This is the time for Strait Science audience to show a little love in the chat box or in the chat for Jim. It's never easy to be a Strait Science speaker or a public speaker, but thank you, Jim. Some good info there. I know I've got some questions, as I'm sure people do online. So you're getting lots of chats or claps, and people are much more savvy at Zoom than me. So they're very good. Thank you, everybody. That's great. We'll open it up to questions. You can put something in the chat. or raise your hand. I see no callers on the list, so you should be able to make yourself known, either unmask yourself or raise your hand, that sort of thing, or put something in the chat. So I know I have a question. I could not hear when you said, what do a large number of jellyfish, what does that indicate for the ecosystem?
Well, like I said, it's like it's not really clear. We don't really know for
Okay.
sure what it means, but it is generally considered to be a good thing. When you have a lot of jellyfish, it means, I think a lot of people infer that to be that the productivity, the overall productivity of the pelagic ecosystem is better because it produces more jellyfish. But other people, like, a lot of jellyfish is not a good thing. But I think in general
I
it means good productivity.
I always look at it a little bit as, I think there's an increase overall, and that's sort of an opinion of mine, but because people keep saying, wow, we've never seen this many jellyfish. And actually, I look at them as a competitor. Don't they eat copepods and small
Yeah, yeah,
zooplankton? So I look at them as a competitor for things like bowhead, right? Or the auklets, things like that. So I kind of have I kind of cast a little doubt on the
yeah. I
big
think there are
jellyfish, but I
positives
don't
and
know.
negatives. Yeah, that's what I'm
Okay.
saying. I think there's positive and negatives, but
All
you
right.
can't get a lot of jellyfish if you don't have a lot of food in the water column. I think that's what they're saying. But
Right.
they can also have a negative effect.
Yeah, they kind of gum things up like baleen and nets.
Yeah.
So, but let's go. Charlie's got his hand up, and Loretta, I see you. We'll get to you next. Go ahead, Charlie.
Oh, thanks. Yeah, I love these talks. The just out of curious or a point of interest, I think my wife and I were down the coast at Penny River mouth last fall, and I've never seen that many jellyfish washed up in the mouth of the Penny River. I guess they were dying in the fresh water, but there was just a lot of them and good
What?
size.
What's? Yeah. What? Do you know what species it was, or was
Were
it a
they?
clear?
They
Did they have
were,
those brown stripes?
yeah, brown stripes and short tentacles. Not the Medusa kind, but the jelly regular jellyfish. I'm not good at that. Yeah.
Yeah. No. No. It's interesting. There's. Yeah. So what? And typically Chrysora melanaster. I don't know, where's this distribution here. Yeah, I mean they tend to be a little more abundant further offshore, but they can be found throughout the shelf area. Uh, you end up getting Aurelia, which I haven't shown here. It's a moon jelly. It's the name. So they have like the four lobes on them. They tend to be. That's where you see a lot of them in Norton Sound and in that really coastal area. You're muted.
Thanks. I had every clock banging off at 7 o'clock. So in the chat, we have a question
So
from Loretta Brown. Thank you. Thank you. Does NOAA do genetics testing for the chum and Chinook collected? And what is the genetic makeup of those caught in the 2024 survey? And one other question, will we see increased numbers of chum returning to Western Alaska rivers?
Oh yeah, that's a good question. Yes,
There's
we
three
do
questions in
genetic.
there.
Yeah, so we do genetic. Sorry, got a virus scan starting here. We do genetic. We collect genetic samples from all of the chum and all of the Chinook. Um, we don't have results back from the 2024 survey yet for chums, but we do have results from juvenile Chinook, and but I haven't updated the figures to be the stock specific abundance estimates. But in general, what you find is, there's like 45% of the juvenile Chinook are from Canada, so the Canadian origin Chinook. They make up a large percentage of the Chinook, and I looked at those numbers, and it's nothing is out of the ordinary. They're right typically where we expect the proportions to be, and I think the one stock group that we can identify genetically so far is the fall chum salmon run in the Yukon River. All the summer chums tend to be kind of too genetically similar to break them out into the different groups. And typically, on average, fall Yukon River chum salmon make up about 25% of the chums that we catch in the Northern Bering Sea. And was there another question in there?
Will we
Remind me, Dave.
see, will we see
Oh, yeah.
increased
I
numbers
thought
of
there was.
chum?
So the chum salmon models are really tricky. We don't have the same relationship that we for chum salmon as we do for Chinook. Chinook have been pretty stable. They have a relatively stable survival up until ichthyophonus. So we can project future run sizes with a reasonable degree of confidence just based on the juveniles. But for chum salmon, there is the condition and the lipid content of chum salmon probably plays a much bigger role than necessarily their abundance. But we know their abundance is above average, their condition was about average. So I think that we should see fairly good numbers, but we don't have a forecast model that can say exactly what that forecast for the run size would be. So chum also spend 3 or 4 years. So it could be 2 or 3 years before we really start to see the improvement of chums in like back up to the levels that everyone wants them to be.
All right, thank you. There is, hopefully that answered that last question. There's a question in the chat from Megan Williams. And actually, Jim, you might want to stop sharing so people can see you, because right now, if on computers,
Oh, okay, yeah, I can do
you may
that.
be pretty small on most people's computer and they may want to see you. Megan Williams writes, thanks, Jim. Is there an equivalent forecast in the works for non-Canadian origin Chinook salmon based on the surface trawl survey data?
What we have 2 forecasts. One is for the Canadian origin stock group, which typically makes up about 50% of the run, 45 to 50% of the run. And then we provide a forecast for the total run to the Yukon River. So we combine all stock groups, US and Canadian stock groups. So we have a forecast for that. It performs about the same level of accuracy. In other words, it's fairly informative, but the year-to-year variation in the total Yukon forecast is different than the year-to-year variation that we see in the Canadian origin forecast. So some of that is probably our sampling for genetics that we might not be getting the proportions exactly right. So I think there's some of that don't really understand all the same variability. There's an interest to have something developed for like Northern Sound, Chinook. The problem is that they occur at such a low proportion that I think we're going to end up with a fairly large error in estimating the abundance of a small stock group like for Northern Sound. But there's we'll see. We got to fix some of our Chinook models for ichthyophonus, and maybe at some point we'll at least be able to identify the Northern Sound stocks. The problem is I think we're going to have to use something like strontium isotopes in the otoliths, because genetically I don't think they're going to separate out from the lower.
All right. Thank you, Jim. And Katil had a message in the chat. Thank you, Jim. How was distribution of Pacific cod in 2024?
So the only cod that we catch on our survey is the juvenile, the age 0 stage. And we don't catch a lot of cod. We did see, I think last year or the year before, we saw a big bump up in the numbers of age 0 cod, but those numbers haven't held. So I know we caught a few, but probably, less than 50 A0 cod, which is a really fairly low catch numbers. But there's interest by a number of folks to get a better handle on some of the A0 cod work and data that we collect on our survey, but that work hasn't really gotten much attention, largely because of the very limited numbers that we catch on our survey.
All right, and Megan Williams for the other question had wrote, thank you, you answered her question. And Loretta Brown writes, yes, thank you that you did answer her question. And she has one other, is there a link where we might be able to find the slides and corresponding reports? So you mean Loretta for the survey? This survey? Yes.
Yeah, and I talked to Gay. I can share a link to her for this presentation if you would like to look at it, and maybe from there you can share it to other folks. I'm not sure how to do that. What's the best way to do that?
So if it helps, these all are archived and put out, these presentations are put out on YouTube. So there is a Strait Science YouTube, STRAIT. There's a Strait Science YouTube site, and there's like, I don't know, there's like 150 of these on there. And so this will be at the sort of at the top of the list. But is there a NOAA? Eventually the data you're presenting here will be in like the ecosystem status reports, or?
So yeah, I produce reports from the survey. It
Yeah.
takes a little while before those reports are finalized, but we should have the 2022 and 2023 reports out here, hopefully by the spring, and the 2024 survey results, which I'm mainly including here, will be sometime over this next year.
And will they be available on the NOAA Alaska Fisheries Science Center Juneau site? Okay.
You can always go to like AFSC reports, and that will have links to all the survey data will be published as a report at the AFSC. These will be process reports. So what we
So
call
if I go to the
data reports.
So there's a big NOAA Fisheries publications. Would that be in there?
Yeah.
Website?
They'll have a list there of the recent publications. So
okay,
and
so
anybody that wants a copy, I mean, we can always collect emails, and when it's available, we can send out a notification that the report is published.
Okay, and while Jim's talking, I'll try to put his contact info in. And I just put in the chat it's sort of like, it looked like NOAA Publications Fisheries. I hope that's the right one.
Yeah, and that, yeah, too, you can always just reach out to me directly, and I can send links to reports.
All right,
Happy to
Loretta
do it.
says, awesome, great, thank you.
Yeah.
So
yeah, definitely just, if all that is not so clear, just email me, and I'll put you on a list of people that I'll notify that the report is ready for distribution.
And then we've got another question in the chat, and Charlie, I see your hand up. So Jared Stone in the chat was waiting longer. Is there any evidence of hatchery production juveniles from other countries outcompeting wild stock juveniles of Alaska?
Yeah, that's kind of a mixed bag. If there is competition, it's happening in later stages of their life, potentially in the Gulf of Alaska, because a lot of the chums, they migrate south. They spend typically 3 or 4 years in the North Pacific and the Gulf of Alaska, and I think there is concern that hatchery fish will compete for food for wild stocks, but I think the bigger question there is how much does the overall productivity of these high seas ecosystems. It may not be an issue at all when the productivity is high, but when the productivity gets quite low, then I think that there is potential for competition. So what is the problem? Is it because of competition, or is it because the productivity of these ecosystems have tanked? So, but yeah, I think that's where I would say that there's to nail down specific evidence for that is difficult, but I think you can infer that there will be more competition when there's a lot less food out there.
All right. I've got your email in the chat for people to grab. Thank you very much. Go ahead, Charlie.
Yeah, I got cut off earlier and didn't get my real question out.
Uh-oh.
I
Sorry.
had the question about Pacific lamprey and how large are they when you catch them at sea? And I've seen the ones in the river that are tiny, but and I guess many people don't realize how many there are in the local streams. And I'm really curious about that. I don't know. So.
Yeah, so it's like, it's like, what is the age of lamprey and returning to the river? And we actually are making some progress on removing stateless. We have a graduate student that's figured out how to dissect stateless out of lamprey, and so she's starting to look more at what the age structure is. But it's actually really challenging to find the stateless in lamprey. But in general, if you look at the average size of lamprey, just look at mean size in our survey, and then you look at the average size in the river, and they're probably what about, I mean, I'm just throwing a number out. I'm just guessing. They're like 20% have a weight that's like 20% lower than the average weight to the river. So I think a large portion of these lamprey actually come out to sea, spend 1 year in the North Bering, and quite a few of them return to the river. So that's where I've always felt it's like, I think the Northern Bering Sea, which we get estimates of biomass, so we can do numbers, but it's kind of biomass. What is a biomass? I think that a large portion of them are actually returning to the river, like in November-ish. That because there's about 2 months before from when our survey happens to the time they start returning to the river. So
yeah,
that's what we're thinking.
So we were pretty successful at capturing lamprey in the Fish River near White Mountain with a rotary screw trap. They're really small, like less than 3 inches, all of them, and their jaws were still working and not a suction cup. But then I've seen, lamprey attached to salmon, even in Kotzebue, that are 8 inches or that size. So, I don't know.
Yeah, I would say these lamprey that we catch in the North Bering are probably about a foot long.
Yeah.
And some might be a little less, but they're not big.
Right.
They're not like Pacific lamprey that can be a couple feet. They're actually relatively small. Yeah, so it's really interesting. Yeah, this year I was even seeing kind of like what appeared to be lamprey bites on lamprey.
Yeah.
So yeah, there's a lot of them out there, and I don't think it was. Anyway, interesting though.
I have a story I have to tell you. That I was at the office in Kotzebue being a fish and game biologist and minding my own business, and a guy came in and threw a lamprey on my desk, splat, and said, "This was on a salmon in my river, the Noatak River. What the hell is it doing there?"
Yeah.
Apparently I was responsible, but
Yeah,
anyway, yeah. Anyway.
How did you let this happen?
Yeah. Yeah.
Well, as chum salmon swim through the North Bering, they'll pick up lamprey on their way through. So,
yeah.
So Charlie, I have a question for you. I don't know anything about lampreys, and I Googled it up real quick, and it says it has a rich, fatty meat, which sounds delish. is there a fishery in our region? Do we fish subsistence or
Yukon-
commercial for lamprey?
On the Yukon,
Okay,
they fish for them just as ice is forming, and they have a migration that goes up the river, and they have like 2x2 sticks with a bunch of nails driven through the end like a spaghetti wand,
okay.
and they sweep them around under the ice and come up with buckets full. And the run is only a couple days long, and as it goes up the river, people are following it and talking village to village. Lampreys are on their way. Come get them.
That's awesome. I'd like to try one. Cool. Learned something. Thank you, Charlie.
Yeah.
Thank you, Jim.
Yeah. I think there's a subsistence fishery on them, but there's also, in the past, it's been a while, but there's also been a commercial fishery. And I think the market, and Charlie, you probably know this, is like on the East Coast, where, the East Coast folks are used to buying eels and smoking them, and that's what there's been a market, small market for them. But
All right. Any other questions? I have one for Jim, and that is what I've heard is like this was interesting. So thank you for giving us the info tonight. The zooplanktons, that was a good news. These lamprey, that was good news, I hope. And the capelin looks like good news. And my question is, are these, all of this is sort of, they're up because they're recovering from what we experienced a couple years ago when we really didn't have a lot of ice. So that looks good. There's still some things that are troublesome. And as I mentioned earlier, we have a difficult ice situation for those that may be listening from afar. Our ice situation is, I think someone said, ominous. And I would agree with that. The shore fast ice broke off of Nome for the first time that anyone can remember, February 11th, second week of February, which is supposed to be our coldest month, and it is thin. And I'm just wondering, it looks like we're getting some north wind, the ice is extending. All it's probably going to take is a couple of good southerly lows. Given that we're highly ominous, what do you think might happen? I know you can't really say, so maybe this isn't fair, but do you think we're headed where this recovery, if that's what we're seeing, and they're saying this, maybe things are like coming back? Any ideas? And are you coming back next year so we could get what happened, whatever happens next in 2025 for the Bering Strait region? Will you be out there? And maybe next year we can also hear from you some preliminary what you found, because it does feel a little we're on shaky ground as far as a normal sea ice situation. We're far from it, I think.
yeah, and yeah, assuming I still have a job, we'll be back. I think we're planning to, but there's a lot of uncertainties with being a Fed at this point, so we'll see.
Sure.
But yeah, you're right. I think conditions were good, cool, and I think I think particularly capelin, seeing the numbers of capelin come back to me is like, that's what we need, and that's what we want to see. But even here in Southeast Alaska, we're having just an exceptionally warm winter. And like what you're saying is that we're seeing evidence of just a really warm winter. So I don't know if I was if I were to bet on it, I don't think that these cold conditions are going to last. I think we'll be either back up to average or above average temperatures, which will be, not as good.
If the Gulf of Alaska is warm and the Southern Bering Sea is warm, will that, regardless of us, will that push your Gulf of Alaska fish or Southern Bering Sea fish just trying to get cooled
Yeah,
off.
yeah, I
Or
think there'll be more movement. We definitely see like a lot more pollock, the A0 pollock, not it is what we sample is up in the water column. So those are the, we see a lot of them move up there. You see the cane flood numbers really drop when it warms up. And we also see things like the lipid content and the fat in copepods really drop when it's warm. So all that is probably set up by ice algae so that when you don't have that ice algae, then a lot of these large copepods just don't have the food reserves to build fat content, which has the upstream effect to the food chain. That now
right.
fish that are dependent on zooplankton prey, they can be negatively affected by it. But other species that feed on fish, they're kind of buffered from that.
Well, for us, the algae is the base of the food chain. So if we
Yeah.
don't have stable ice of long duration and high quality, that where all that algae's all in there for all the krill to come on up, and then the little fish like capelin get in there and start doing their business, and then birds come in and we come in and eat birds and fish and all of that. It just seems like we might, not to be a Debbie Downer, but it'll be interesting to see what happens as we roll into whatever summer 2025 is, spring, much less summer 2025 is going to bring us. So we really appreciate what you've learned for 2024 and kind of how to wrap our heads around that, and as we move forward into the 2025.
Yeah, yeah. Hopefully, yeah. I just have a feeling that we're not going to be. I don't think we're going to be back to like 2019 situation, but it'll probably be warmer than obviously any cold year. That's the reality, is that any cold year that we see is not going to be like, oh, return to normal. It's probably going to be very short lived, and we'll be right back up into average or above average temperatures.
All right. Well, thanks for cheering us up, Jim.
Yeah.
Honestly. But I think that is our reality.
You
Jackie,
gotta
did you
start
have,
eating lamprey. Yeah, I gotta.
yeah, Jackie,
gotta,
did you have anything to add or question for Jim?
No,
for it.
no,
yeah.
I'm just listening to what he had to say, because I think that's what we're feeling when we go up, coming up there on the Sikuliak, that it's going to be, the question we're debating at our meeting at NOAA that we had last week is the fact that what are we seeing? I mean, we know it's not returning back to what the traditional coal pool area, that in fact
Yeah.
it'll be warmer, and as such the whole ecosystem is more, it's not going to be as bad as probably 18, as warm. But from Phyllis Stabeno's work, that the moorings were so warm on the bottom last year, it's going to be hard to get it cold enough this year.
Yeah.
And the other thing I would say is that you talk about lampreys. We had them in Korea once. They're not my favorite animal, but eel
mean-
I like.
You mean for, you tried them at a restaurant, commercial?
Yeah, well, we were in Korea, so they had them in tanks in this little village where we didn't speak English. And so we'd had little cards that we ate chicken. We just drew a chicken because I just wasn't going to eat a lamprey.
They
But
sound
that's
good.
all the options. You had a chicken or you had lamprey. So I didn't want a lamprey.
Yeah.
All right. Well, thank you. Thank you, Jackie. Any other questions, comments, thoughts for Jim while we've got him?
No.
All right. Hearing none, people can Budinsky. We're going to take next week. We do not have a straight science lined up. I was going to travel, but that's been canceled. And the next straight science will be March 13th, and it's going to be Rick Toman. And this time he's not talking about the forecasting for the spring, although I hope he will later. He is actually working with several other people on a project looking at the timing of our fall ice arrival, and then the weather, the coastal flood risks that Nome is experiencing. And I think he's probably looking at some of the economics of that. And so he and several others are looking at, for Nome, what does this mean for us here in the region as he's going to go through the storms in the fall, and then that early retreat of the spring ice as well. But what it is what are the impacts on this community with those fall storms and the later arrival of ice that seems to be just persistent. So that ought to be very interesting. That'll be on Thursday, the 13th. There will be no Straight Science next week. And we're so glad everybody came. And we'll see you all next time.